Hello, in this video we are going to look at how to reverse a single linked list and also compute the time complexity and space complexity of the solution that we will build in this video. Before jumping into the solution, let's understand a brief overview of what a single linked list is, and then we can go to the solution aspect of it. Basically, we have a node and these nodes are connected to one another. Each node is going to have a value and a next pointer associated with it. For example, a value can be 1 and the pointer will point to either the next node or null. If it's pointing to null, that means it's the last node in the linked list chain. In this example, let's take an input of 1 pointing to 2, pointing to 3, pointing to 4, pointing to 5, and then let's say this is the last node and this node points to null and the first node points to head. In a linked list, we represent the first node using a head pointer and the last node is indicated by its next pointer pointing to null. And when we try to reverse a linked list, the output that we expect after the implementation is something like this. The last node will become the first node with the head pointer pointing towards this node. So this now becomes the head pointer, and then we will have the remaining nodes just in the reverse sequence of the original list. And then now the initial first pointer, which was node 1, will now point to null, indicating that that's the last node in the linked list chain. When we go to the solution aspect of it, let me say we have this list node function, and this function has value and next associated with it, and which can either be null or next, which we discussed earlier. So a value, a next pointer, and then if it's the last node, it's going to be pointing towards null. And we have a recursive function here which we are going to use to implement the solution. Now, one thing to note is that when it comes to recursive solutions, it's like we are going to always return something from the solution. So return something, and then because we want to build a recursive reverse logic, so of course the logic part we will go somewhere in the code, and then because if you don't put a exit condition inside the recursive function, it will go in an infinite loop. We will also need a exit condition. So this will be mandatory aspects that are associated with a recursive solution. And let's try to think a bit into what we are trying to build here. So we want to reverse the linked list. So let's just take the first two nodes. Let's say we have this node, which is the head node right now, and this node is pointing to the next node, which is pointing to the third node. This is head and this is head dot next that we have with us. Now let's just temporarily forget that there are other nodes, and let's only focus on these two nodes that we have with us. So this one and the head dot next one. Basically what we want to do is traverse this list node after node. So we will go first node, second node, third node, fourth node, fifth node, and so on until the end. That's why we are saying it's a recursive function. So somewhere there is going to be recursive logic and in the end we want to return this new head based on some checks and conditions, so this is what we want to return. So we will return something and we want to go in a sequence through all the nodes, traverse all the nodes. And to do that, what we will do is we will just call the function again, and in the end we want to have this new head that we want to return as part of our solution. So we will just say return new head, and like this new head is going to be reverse list, and we want to keep traversing it. So we get one input, one node as input here, which is the head, and then head it has head dot next, so we will keep going next to till the end by this recursive call. So it will just get pushed in the call stack, and once you return, it's just going to get popped, and in the end we are going to left with head as 5 here. So when we call this reverse list, we will just pass head dot next and just keep going to the next node in the thread. Now after we have the new head, we just return it, as part of our solution, because ultimately we have to return something, and that something is going to be this pointer having the head pointed towards it. Now coming back to these two nodes, right now we have a connection between node 1 and node 2 with node 1 pointing to node 2. I want to break this connection and reverse the connection that you have, because the whole logic here is that we want to reverse the linked list. And what I want is basically, if my input is 1 is pointed to 2, I want 2 to point to 1. That's my end goal here. So to achieve that goal, what I will do here is something like this. I will say head dot next, which is this one, dot next is equal to, instead of pointing to 3, I will sever this connection. I don't want to have this connection anymore, and I will just point it back at 1 to reverse it. So I will just say head dot next dot next. Head dot next is this one, and the next that it points to is the head itself. And then now this becomes a cycle. See, 1 is pointed to 2 and 2 is pointed to 1, and it's not going anywhere, So we want to sever this collection also, just to cut it off, and I will point this to null. So I will say head dot next is equal to null, and that's our reverse logic here. You just iterate till you reach the end, and then you return the head, and then here you just do the cutting logic and restitch it and reverse both the node connections. Now only thing that is left is the exit condition, and that will look something like, if now till what time you want to go into this recursion, when do we want to stop? We basically want to stop when we reach the last node. So we will say if head is null, or even if it's the second last node, then also we can stop, because it's like, if this is null, we are not going anywhere, and if you know that the next one you're pointing to is also null, then also we are not going anywhere. So we will just say head dot next is equal to null, then you just return head. So once you reach the end here, you just return this one, and then it's going to be backtracked, and the stack is going to get popped. You return from every call, and then it's the nested call stack is just going to get pop for this 5th call, 4th call, 3rd call, 2nd call, 1st call, every time you are reversing the connections between them. And that's pretty much it. So you started with this pointing to this, and then you just reverse the whole connection through the logic of reverse that we wrote here. And that's pretty much it. This is the solution. And yep, now let's explore the time complexity associated with this solution. Now, because it's a recursive solution, what's going to happen is as many number of nodes we have, as many times of recursive call is going to happen, because we keep on going nested inside in the recursive call stack. We keep diving deeper until we reach the last chain node in the whole chain of linked nodes. So number of nodes corresponds to the number of recursive calls, hence we have time complexity as order of n. Now when it comes to space complexity, that is also going to be order of n, because every time you make a call, you need call stack. Of course, you will say that you are declaring a constant here, so this will be space complexity of order of 1, order of 1. But then if you do like order of 1 plus order of n, it comes to order of n itself. So this, if you add together with the recursive call, it ultimately becomes order of n. So that's why the space complexity is also order of n. Thanks for watching. That's pretty much it. Please like and subscribe. Thank you.